Okay, so we're starting lesson 9, and this will be the first session for that. So it's really just going to lay down the groundwork for how we do these problems. And we're really just going to start with comparing, and then later on this week, go into rounding our decimals. So let's start with a warm up. Now, our warm up is just a quick review of how we compare two numbers, and we're just using whole numbers in this case. But we have these symbols here. These three symbols here tell us if something's greater than, less than, or equal. So let's start with the first one here. So we have 238, and we're comparing it with 234. So what we have to do here is decide which number is bigger. So our hundreds places are the same, our tens places are the same, but our ones are different in that the 8 is larger than the 4, so that number is bigger. So 238 is greater than 234. Let's look at these next two numbers. We have 412 and 412. These numbers are the same as one another, so they will be equal. So 412 is equal to 412. We have, and then we're comparing 12 and 108. Well, right away, we see that 12 does not have any digits in the hundreds place, and the 108 does. So automatically, we disregard the rest of the numbers, and we know that that is larger. So 12 is less than 108. So again, that's just a good preview and review of what we'll be doing for the next couple lessons. All right, for the notes, go ahead and turn to page 167. All right, Grace chooses one red button and one blue button from her button collection. The blue button is 1.2 centimeters wide, and the red button is 1 and 2 tenths centimeters wide, and the red button is 1 and 800 centimeters wide. Which button is wider? Best way to do this is to create a place values chart. So we've got ones, tenths, and hundreds. All right, so our blue button, which I'll do in blue, is 1 and 2 tenths centimeters. The red button she pulls out is 1 and 800ths. And now we have to compare them and see which button is wider. So now it comes down to just comparing place values, just like we did with the warm-up. Our ones match up. They're exactly the same. So we move on to the next place value. In this case, the blue button is larger by 2 tenths in the tenths column. So that's how we can tell that the blue button is the wider button. And as far as this goes, we ignore the 8, although kids will be tempted to say, well, an 8's bigger than a 2, and this is 3 digits wide, and the other one's only 2 digits, but that's why place value is important, and just go by the place value instead. All right, go ahead and turn the page. And it's going to ask us which button is wider, and that would be the blue button. And use the greater than symbol or less than symbol to write an inequality statement that compares the widths of the red and blue buttons Grace chose from her collection. So that's pretty simple. We just going to list 1.2 and 1.08. And we know from going through the place values that 1.2 is greater than 1 and 800ths. Just as simple as that. And this word inequality simply just means anytime you see these symbols, it's going to be related to that. All right, let's move on to the next note. You can use decimal comparisons to help you round decimals to a given place value. Rounding decimals is similar to rounding whole numbers. So I will say this, the rules are generally the same as far as whole numbers and decimals. So if you can round whole numbers, then decimals will be fairly simple. So let's start with the way of doing it if you use a number line. And rounding works by you round to the place value that it's closest to. So if it's saying in this case, for this number line for A, like what's the nearest whole number, either 1 or 2 for 1.3 and 1.8, we can use a number line to visually see that. So let's put 1.3 here. It's like 1, 2, 3. All right, let's put 1.3 here. And then let's put 1.8 here as well. So we've got 5, 6, 7, 8. And here's 1.8. All right, so let's go to B. B asks, what is 1.3 rounded to the nearest whole number? So you literally have to think about which one of these is it closer to or nearer to? And that'd be pretty easy to see that it's closer to this guy right here. So it'd be closer to 1.0. And to explain it really simply, it's closer to 1. It's just simply closer. Let's look at 1.8. What's that rounded to the nearest whole number? So it's literally nearer to the 2.0. And the explanations, it's closer to 2. So, but here's a question. What's 1.5? Right in the middle. What's that rounded to the nearest whole number? So here's where we've got an exception, but it's a rule that we've talked about before in previous math. So if you have something exactly in the middle, it's going to round, in this case, to 2. So when a number is exactly halfway, we round up. Mathematically, it's just a decision that was made decades, centuries ago, and it's just what we go with today. All right. Let's look at this last question here. Again, this is just short notes. How is rounding decimals like rounding whole numbers? The basic thing is this, and we just demonstrated it, but maybe we didn't pick up on that just yet, but they both use the same rules. And those rules are round to whichever value is closer, and exactly halfway means round up. And that's it. That's all your 3 keys to, well, 2, but your main keys to rounding decimals, rounding numbers in general, are those rules right there that you've just written down. All right, so get a little practice comparing decimals. I've got the following IXL set up for you guys. It's going to be G13, compare decimal numbers, 70% to complete the lesson, and then if you go to 100%, you'll earn yourself an extra house point.